Okay, we're back. This is cured up overnight. So I've taken the tube out already. I did clean it off from the PVA. So you can see inside there, our glue's dried up fully nice and hard. The glass is set. So everything's in there good, nice and solid. You know, the socket hole through the fuse is clean. No glue. That's why we have the tube in there. So when you're squishing that in, you can't get a bunch of epoxy squished through the cracks. So that turned out good. Then rotation pins in there, nice and solid, can't move, so it's not going anywhere. And you can see our tube fit is very good as well. So all the way through, there's like almost just a hair of flex it or slop in that socket, which is fine. Once we get the stab finished up, you know, and we put the retention bolt in and the anti-rotation pins on and the wing cap, and there'll be or the root cap, and there'll be a bit of foam. We'll put a bit of that foam padding on the root. When you put all that up, I mean, just the fact that both the stabs are on there tight up against the fuse, it'll take all that slop out. So it actually won't be a sloppy fit at all. And also our tail wheel support is in there, nice and solid, so you got something to screw or glue your tail wheel into. So whether you use the tail wheel that comes in the kit, which is one like this, so like the old MK style, tail wheel, so a couple two screws to go into that hard point, or you use a Nishioka style with a pin that comes up, or a tube that comes up through here. Either way, you do need a bit of support in there, or you want a bit of support in there to screw into. You don't just want to put it right into the width of the fuse. So with that done, before we move on to the wing, and just to finish off in the tail, I'm going to do the rudder servo mount back here. If you're not going to use a push-pull rudder, and you're going to use a pull-pull rudder, you obviously don't need to worry about this step. But if you are using a push-pull rudder, I'll show you how to get that in there. So to get the cutout in here properly for the servo, I've made a template. Now, I made this template a long time ago. This is actually from the XS biplane. I created this template, so it fits the same. I mean, all the Pascal does the planes. Basically, the socket and the anti-rotation pin are in the same spot. Slightly a bit further behind the trailing edge from where my original template cut it, but it's okay. I'm just going to leave it like that. So I'm just going to use that cutout exactly the way I had it. I did put some tape on the fuse here just to draw on. Now you want to make this for whatever servo you're using. In my case, I'm using BLS 171. So it's a full-size Futaba servo. So all full-size Futaba servos are basically 40 millimeters on the case, 20 millimeters wide, and 55 millimeters to those endpoints there. You could use something smaller. I know guys do use like the tinier servos, like a BLS 173, which are quite a bit smaller, as you can see. So you got to make sure that whatever your hole you're cutting in there is appropriate for the servo that you're going to use. So it'll take you a little bit of time to figure this out. I've made this cutout perpendicular to the rudder hinge line. So for that, you just use a square, and you just square up on your hinge line there, and you just make sure that the center line of that cutout is straight down the perpendicular mark from the hinge line. And it's just a geometry thing. I mean, you could put your servo at a different angle, but this makes it nice and easy when you square up your servo arm. You just square it up to the case on the servo. The other benefit of putting a servo in this orientation versus say this orientation is, from a stiffness standpoint, it's a lot harder when a servo is bolted down this way to move it like that. If you're getting blowback or when the surface is deflected and it's pushing, it's a lot more rigid in this axis than it is in this axis. So you just get less slop. in the surface at the end of the day. So once you get that, once you get your template on there, you just mark it off. Now, always double, triple, quadruple check. So in my case, that's how that servo will sit in there. The entire servo, including the screw mounts, will drop into the fuselage. So we're just going to go ahead and mark that off so we can cut it. I do like to make a lot of templates when I'm building these planes, because if you build another one down the road, the templates save you a lot of time. There, that's that. So you see there's our cutout. So we're going to go ahead and we're going to hack that out with the Dremel tool, and then we're going to work on building the actual balsa wood inset for the servo. So again, handy dandy cordless Dremel with that diamond little cutoff wheel. So there we have it, that little part's cut out, all good, so we don't really need the tape on here anymore. We can take that off. And then I do like to just sort of finish it up a little bit, so I just always make up a few various little sanding things. This is just a piece of wood with some paper on it. There's our cutout. And you know, if we test fit our servo in there, it'll likely be pretty snug. That's just fine. It's always easier to remove material than add material, so it is a little bit snug, so we can just kind of keep adjusting that with our sander until we get a nice little flush fit in there. Okay, so I've cleaned this hole up a bit. You'll see the servo now goes neat and tidy in there. No issues, just a little bit of room to move around there. So now we're going to go about making the former that's going to sit in the back of that fuselage and support all the servo mounting. So again, I've had a template from my previous plane, so that's basically what it looks like. So what I've got here is sort of a trapezoid shaped former, and that's going to be top and bottom. And then where the servo goes, that's these two lines, that's going to be, you can imagine this former is going to sit in the fuse this way. There's going to be two of them, top and bottom, and then wood's going to go in this direction, and the servo's basically going to sit in between these two formers like that inside the fuselage. Okay. So how did I come up with that former? Well, there's a couple ways. One, you could have used the tail former to generate that shape, and then just, you know, use whatever position along there you need. Or two, you can just measure up inside the fuse, kind of at the front here, you know, and that's about 43 millimeters across, and then at the back, which is about 37, 38 millimeters across. So these formers were from my excess. It's pretty close. It might be a little bit bigger. So I'm probably just going to go ahead and use them to make the initial cuts, initial parts, and then I can size them accordingly, just to make it easier for myself so I don't have to create another template. But in your case, measure that up, create the template. I use about, you know, the servo is going to sit like so in there. So I have about, what is it here? About 25 millimeters or 1 inch of basically extra former length past where the servo is going to be mounted. And that's really just to give me lots of gluing surface, you know, an attachment to the fuse. So I'm going to go ahead and cut these out. Probably use like 1/8 inch balsa or 3/32, whatever I've kind of got hanging around. Okay, so I've gone ahead and cut out my two horizontal formers. So essentially how these are going to sit, they're going to sit in the fuse like that and bound the two sides of the servo. So then I need to cut the two vertical pieces that are going to sit in here for effectively where you're going to put the servo screw rails in. So Really, they're going to be 20 millimeters wide to match the servo. And then whatever the width of that cross section is at the point you're going to mount the servo. So the servo is going to essentially sit in here, sort of like so, right? So on my template, I had already marked those two lines where the servo is going to sit. So I'm going to use that then to mark off those two locations, and then we're going to measure across, and then we're going to cut out a couple more 1/8 inch pieces, and then basically build our little servo box. So that's those 2 points there. So essentially the front one's going to be about 46 millimeters wide, and the back one's going to be about 42 millimeters wide. Now if you want, we can go ahead and trial fit this. It doesn't really matter. Once we slide it down in the fuse and we start fitting it up, we'll know pretty quick whether it's going to line up with our box, and we're just going to kind of keep adjusting that till it does. Then we're going to glue it in place. So I'm going to go ahead and get those pieces cut, and I'll come back to you in a minute. Okay, so I've got the cross pieces cut. Now I cut them cross grain, so this way. I don't know if it matters that much, but it seems smarter to me. So they're basically going to sit like that in that former, and then the other former on top, and that's effectively going to form the box for our servo, right? So that's basically what that servo box looks like at the back. So again, servo's pretty tight fit in there. Maybe a bit too tight. We can always sand the edges off, but you know, I'll try to make this stuff as accurate as I can get it so I don't have any slop in that servo. The tighter we get that servo in that box, really it can't move anywhere, so then it can't have any slop. So I'm going to go ahead and glue that up. So again, we try to keep everything as square as we can get it. So I'm going to use my little square here, take it off. I'm just going to use thin CA. Make sure you're gluing on the right side of the lines so you don't mess anything up. Keep it square. Go. So there's basically how the servo is going to sit in there. We can put the holes in for the cable afterwards. So that's the one side done, and we're really, this is the other side now, we're really just going to line that up best we can. We're trying to make these parallel, so best to put kind of one side on the table and hold it in place. Get the ends as even as you can. Try not to offset it too much, and then we're just going to hit this with some thin as well. So there's the base of our box. Doesn't really necessarily matter which way we put this in, whether it's this way or this way. At this point it's the same. So we do need to put a floor in here. So what I'm going to do is we do have to kind of figure out, and this is pretty tight, I'm probably going to have to sand this down a little bit. So what I want to do is I basically want to have that servo essentially flat on the outside of the fuse. So this is going to sit inside the fuse like that. So there is going to be the width of that fuselage, which isn't very much, you know, it's a millimeter or so. So I kind of want that servo, the case, sticking out about a millimeter past the top of that, servo, or past the top of that wood, right? And that way when I put it in the fuse, I'm going to have just, you know, it's just barely going to stick out. So I don't want to have my floor any lower than that. So, and I, you know, maybe you don't even need a floor in there. I like to put one in just so it's neat. So when you pull the servo out, you know, it just looks like a servo box. You can't see down into the fuselage, just from a neatness standpoint. So I'm going to go ahead and build a 20 by 40 millimeter floor. and stick it in there. Actually, it's going to be 55, I guess, because it's got the full width of the servo. So 55 by 20, and I'm going to stick it in there just so it's not touching the edge of the servo. I'll probably set the servo in flush, and that way I got a little bit of adjustment room once this thing is actually mounted up in the fuselage. So I'm going to go ahead and build that and come back to you in a minute. Okay, so I've gone ahead, there's that bottom floor piece. So really, that's just going to slide in there. And then what I'm going to do, or try to do, is I'm going to try to use the servo essentially to set that as the bottom. So I'm going to slide the servo in kind of where I want it. Remember, I'm going to put that flush with the top of that. And then really, now that that's on the bottom, I'm just going to push the bottom of this up against that servo, and that's essentially going to set my floor. So it'll look something like that. I'm just going to hold that in place. I'm going to pull the servo out a bit because I really don't want to glue that servo. Take that all the way out now. Just finish this off. There. So there's the servo box. That's what it looks like. So it's basically ready to go. Other than putting in the cable outlet. Okay, so we still have to cut the hole where the servo lead's going to come out. So to do that, I just use brass tubing, sharpened, and kind of put some teeth on it like that. So make sure you know which way. Obviously this is tapered back, so it's going to sit like that. And then the servo, I always put the servos so that the horn is that direction, just to make the linkage as short as possible. So we're going to put that on this side. So I just eyeball it roughly where I'm going to put that hole, and I just take my brass tube, just get started, and then just finish it off. And it goes through just like that. So we get a nice hole cut in there for our servo lead. So before we're going to glue this in, we want to dry fit this again, just to make sure. Whatever tube you used, you want to make sure that it actually is big enough for the lead itself. So there's going to be our servo. It is going to stick out just ever so slightly by the time I get the mounts in. I will do the mounts in down the road when we actually go to mount all these servos up. I'm not going to bother with it right now. So that's essentially how that's going to live inside the fuselage. Now getting this cable out, you know, it may look tough, but I'm going to cut a pretty big slot in here, and I do have that big hole in the bottom of the former. So you know, with a bit of bouncing around, it'll pop up through that hole, and we'll get that lead through there. So I'm going to go ahead and we're going to start dry fitting this thing in the fuse, and then we'll glue it up. So I went ahead, I've put this in from the front of the fuse. It is, I mean, you probably may be able to get it in from the back, and you have to get it in far and rotate it, which is tough. So I put it in from the front. So you'll see it's definitely a bit on the snug side, so it's too big. This is the back part of the box, so the front part of the box is still up there. So we're going to pull this out. I'm going to very lightly sand each side, and we'll come back and try it again. Okay, so there it basically is. It's maybe a little bit loose in spots, but that's okay. We'll fill it in with some glue. So I'll just zoom in a little bit on it there for you. That's what it looks like. And the reason why I do it this way is because if you try to, you know, cut this slot bigger and put the wood in through this way, you know, you gotta fill it and kind of tidy up the work. But when you do it kind of recessed inside like that, there's no work now to do for painting. I basically glue that in and then I can go shoot paint on this plane. I haven't really done any damage to that fuselage area at all there, so it's just a lot easier from a finishing standpoint. So I'm just gonna line that up, and I'm gonna put some medium CA just really on the edges here. So I'm going to go in the back, I'm going to run some thin CA just kind of on the joint there. That's sort of what that former looks like in the back there now. So I'm going to run some thin CA on that joint just to hold it in place, and then I'll probably go in back with a stick and just fill it in with a bit of epoxy just to kind of make sure I got a good bond there. You can also use polyurethane in this case because it's not going to be directly between the wood and the fuse. It's not really going to expand. It'll kind of expand into the joint, but it shouldn't make the joint any worse. And the fact I'm going to hold that together with thin CA, it'll kind of support that when your polyurethane's drying. So I'm going to go ahead and do that off camera because it's a bit hard to film. Okay, so I've went ahead and I've got that tacked in there now with a CA. I just thin CA and just let it run down just kind of tip the fuse up and let it run down the seam, just so it holds it in place. So I'm going to go back in here with some polyurethane. I just put a little bit in a cup, and I'm going to use like a barbecue skewer, just a long toothpick, and I'm just going to pick it up and I'm going to make a little fillet in and around the edges of the former. So really that's it for the inside. Filleted it up neat around the edges there. A bit hard to see, but a glue will set up in a couple hours, and then we can tidy up the cutout. Now the cutout, you know, like I said before, I do it that way just because it turns out really neat. I mean, there's very minimal work to do on that, basically to get it ready for finishing and also for flying. I did end up with a teeny weeny, you can kind of see it right about there. Do it, not too big of a deal. So like I say, the more accurate you make that former, the less of those things you'll have. You know, the other side, you know, same sort of thing. There might be a couple little ones, but they're under the stab. They're not as easy to see, so I'm not too worried about that. Anyways, that wraps up basically installing the servo box for the rudder, and really that's all the work we really need to do back in the tail. We won't put the tail post in the model until the end. Next thing I'll work on is getting the wing alignment done, root rib, and those sort of tasks.